Welcome. Good morning, everybody. Uh, both to those who are here in person and those online. We have a great talk today by a great person. Many of you know Katie Allen, who has had a interesting and varied career. She started here at Regenstrief way back in 2008, and she worked in the Center for Biomedical Informatics for a period of time. Then, much to our chagrin, and to others not chagrin, she moved to the VA for a period of time where she helped out in that program. And then happily, Katie returned to Regenstrief and has worked in data core on a number of different projects and initiatives. And most recently, she joined CBMI as a data scientist. Katie is also working on her PhD at the Fairbanks School of Public Health. So there's lots of stuff. I know that Katie has lots of stories and experiences. Today she's going to talk about data, and I'm not talking about the robot from Star Trek. We're going to talk about information. But the last thing, I'm going to do just a quick quiz. Okay, prior to coming to Regenstrief in 2008, where did Katie work? Was it A, Cummins, B, NASA, or C, Northwestern? Where did she come from? How many people think it's A? Raise your hand. B, raise your hand. Oh, everybody knows Katie. And all right, yeah. So she came to us from NASA. So without any further ado, Katie, take it away.
All right. Well, thank you so much for having me today and for an interest in this topic. I appreciate Cameron and Joyce inviting me to speak about data scientists and what we do and how we might be here to help you. It's really great to be back presenting in person, to actually be standing and interacting and being able to see people's faces. I think one of the things I miss the most about talking the last few years was always you were talking to these little gray squares and sometimes you could see faces and you never could really gauge anybody's interaction. So hopefully I haven't lost my ability to dial it in if I see you nodding off, but I'll do my best. So again, thank you for your interest in the topic today. And I guess before we go, I was going to introduce myself, but Sean really covered most of it. I'll just say when I'm not working, I'm with the goofballs on this screen here. We like to explore and hike. We actually just got back from Mexico. And so this is one of our hikes. And Nora would be mortified that I am showing this, which is why I'm doing it. So she's the little one. One of the things I wanted to mention though is, when I joined Regenstrief, it was for a move to Indy, not because I necessarily knew anything about health research at the time. I'd been working primarily in space research and space themed education, but we needed to move to Indy, and so somebody gave me a chance and said, "I think your skill set is portable." And I have to say, I love what I do. I have since become so enamored with the idea of health research and what we can do to make healthcare better that I decided to make it my calling, which is why I joined the PhD program. And I'm hoping to be finished sometime next year. I'm in my dissertation phase. So if you see me looking stressed out or very sad, like somebody may have just, written no all over a document I wrote, it's probably true. And just pat me on the back and send me on my way. I guess the other thing I'll mention is I don't have any conflicts to report. I'm a staff. I don't receive honorariums from anybody, and I don't get paid for telling you how awesome data scientists are. So, all right. So for today, I'm going to be talking to you about the role of data scientists, but I'm going to come to this from kind of the research landscape and the changing environment that we have. I want you to understand what data scientists do, so that hopefully maybe at the end of this, you want one on your projects, right? That's my goal. To do that, I'm going to set the stage, looking a little bit at how data is today. We'll talk about the key roles and skill sets that data scientists have and how these apply to the current landscape. And then that fourth learning objective, I hope you're going to handle on your own, right? That at the end of this conversation, you'll say, I know exactly how a data scientist can help me on this project. And the other thing I want to mention is I'm going to be using a health research perspective. So I'm coming completely from that viewpoint. So when I'm talking about data collection or data environment, I'm talking about electronic health records. I'm talking about it from the secondary use perspective, from not the clinical gathering or how they can necessarily be used in treatment, but specifically from a research perspective. And I'm also coming to you from that same lens with regard to data scientists. So data scientists are everywhere. People are, I mean, like Target employs data scientists. Everybody is employing data scientists because the world has changed so much with regards to data. But the environments are different, right? I think there's ways that how data scientists are interacting in health research is very different than how business analytics might be deployed. And in some cases, we might even be a little bit better or more ready for data scientists because our ethical considerations might a little bit be addressed because of our governance and HIPAA and things like that. But on the other side of it, we're very set in our ways, right? And research has its methods, and breaking in is sometimes difficult. But just putting it out there that I'm not talking about it from a business analytics side, although you're definitely seeing it happening in the healthcare sector. You can get a job for IU Health as a data scientist, I'm sure, but that's not going to be my focus for today. So with that, I will get started. So I want to start with a question. Just get in your head, what is a traditional health research study? What are we doing? And I'm guessing you might have gone to something very close to a clinical trial in your head, right? You have a question, you set up this study, you design your forms, you decide what data elements you want to collect, what you need to know about these subjects. You go out and you collect this data. We call that primary data collection. And then you come back and you analyze the data and you look for your correlations, your ANOVAs, your regressions. I'm just throwing out statistical terms. But you do all that and you've done your research project, right? And that's probably what you thought about when I brought that up. But the environment of data collection has changed quite a bit, right? Electronic health records in the last 20 years have advanced a lot. We know that better than anybody else here at the Regenstrief Institute because of our history. But even they still refine today, right? You can, the companies have almost made it easier to build in your own data elements. Say, I need to collect specifically this variable to extract out some of these variables. Storage and other technological advancements related to data capture and collection is making it easier to store and extract all this data. Although for tech services and the data analysts, I will put in quotes, easier to extract. It's not easy. But it's a very data heavy world now, right? We've got all of these advancements in the electronic health records. We're customizing our data collection, like I mentioned. We're able to get to these elements in a way that used to be very manually intensive. You had to pull up the charts, you had to read all the details, and then extract all that out. You don't necessarily have to do that anymore. Some studies you still definitely do. But on top of that, on top of the EHRs, we have all this other data that's out there now, right? There's publicly available data sets that have thousands of variables that can be merged and collated to make these bigger analytic data sets. So, for an example, the census or the American Community Survey collects socioeconomic factors across the US. You can connect that up with your patient population. There's tons of other surveys out there. Another advancement is that people are starting to share data sets. So they're either putting them out publicly for encouraging research, or they're making it easier to merge and share data sets across sources. And then something I don't know that we've done a ton of yet, but there's the personal data collection devices, right? And I think some Dr. Weiner I know has done a study where he had the diabetes insulin checks coming in. But I'm thinking more about like our wearables. And just as an example, for the amount of data, this is my workout from Monday. So you can see it gives me right off the bat, the minute I hit that I'm done, I've got an average heart rate. I've got my heart rate for every minute. It has grouped it into zones for me. It has trended it, and it has given me a recovery period, all within seconds of me finishing that workout. And I'm not putting this up there to boast. In fact, the physicians in the room are probably wondering what I was doing in zone 5 there for a while, besides almost dying. What I'm trying to show is the granularity of the data that's now available for people. And these can be merged into data sets. There are multiple studies already leveraging the Apple Watches specifically related to pulse oximetry readings, fall detection, heart rhythm studies. And so this is already being done. But think about the amount of data. Every entry that minute is a data point, right? And how do you collect all that? And then as I've been mentioning, another critical piece is that we can link this, right? And so with permissions and with certain pieces in place, we're able to take the fitness data and merge it up with our data set, take census variables and merge it up with our data set. You've got all these different methods for doing that. You can do it by geography. There's a few people in this room who know a bit about matching on patient identifiers. Depending on what you're trying to merge, this can be easy or more challenging. But now we have the ability to just have all of this data. And our basic studies even are starting to include these extra variables, right? And your data sets are now being enhanced and enriched with data that we didn't have before. And I'm not advancing anymore. Apparently, we're just going to talk about linking data sources the rest of the day. Oh, here we go. There we go. All right. On top of the data-friendly world, it's kind of an analysis-friendly world now too, right? Statistical packages like R and Python are available for free. You don't need a SaaS license anymore to do analysis. And they start to enable some sophisticated analyses because the community around these platforms have built packages. And you can install these packages and conduct these sophisticated geospatial analyses. There's tools out there to help you learn how to do that. Some of them are free. There's multiple YouTube channels dedicated to learning R. I will openly admit I'd be like, how do I? And you can find it very easily, right? And there's a community to support these tools because they are freely available. And so you're able to conduct some of these analyses without having to go find the expert in those per se. And then the other thing I'll mention on the landscape is I think we've seen some methodology advancements. We're seeing more robust research design as it relates to utilizing data. So there's things like difference and propensity scores and regression discontinuities that you weren't hearing as much about 10 years ago as you are now. Like, I feel like now everybody's like, of course we're including propensity scores. Whereas a decade ago, everybody was like, what's a propensity score, right? And these different methodologies help us better simulate the evidence level of a clinical trial, which is still the gold standard for research data, in a way that helps us feel more confident in our outcomes with these big data sets. right? So if you're familiar with some of this in the past, one of the limitations is it was a retrospective data, so it's not a clinical trial. And some of these designs are starting to work towards how can we leverage these huge data sets and retrospective designs in a way that we trust the evidence that we're getting it's meaningful. And we've also seen a bunch of advancements in machine learning techniques, right? We have these huge data sets, and there's advancements in how do we learn from these data sets and what are the statistical methodologies around that. And then also those have become more accepted. People are starting to understand them a little bit better and trust them. So that all sounds great, right? Got lots of data, got free software, got a whole learning community helping me. So why am I here, right? Why? Because it's never that simple. It's always more challenging than you think it's going to be. So let's start with data. It's super complex, right? When you're working with data, especially data you didn't collect, you have to really think through a bunch of questions before you utilize it. And if you don't, you run the risk of making inferences that don't hold, that are not true, that don't actually answer the question you're trying to answer. So you have to think through, how was this data collected? Where did it come from? Right? Why was it collected? What was the purpose? We often talk about this, or when we're talking about using the health information exchange data, it's collected for clinical purposes, right? It's not collected for research purposes. So we have to keep that in mind, because it's not necessarily collected with the rigorousness that maybe we would have done if we were going out and doing primary data collection. And you have to keep that in your head. For whom is it collected? What population does it represent? Right? You don't want to try to answer a question about one population if the data point wasn't even related to them, right? And then what does that variable actually capture? This is especially true when you're thinking about using these publicly available data sets. What is the question the census knocker asked? And what does that mean to this variable here? Does it answer my question or not quite? Right? And you have to be specific in how you're defining your variables so that you can make the right inferences. And you have to be careful with this. And then the other really big one is the data complete, right? And even working with the healthcare data, anybody who's worked with the large data sets know the answer to that's probably no, right? And then you have to figure out, what do I do from here? Do I impute missing variables? Do I get rid of this variable altogether? And so you have to think through, for each of these variables, is it complete? Does it suit the purpose? And is it doing what I want it to do? And then hearkening back to my HeartWatch example, you have data at these varying levels of granularity. And so now you have to figure out, what's the right level I need? Do I need to know what the minute by minute step count was? Or do I just need to know what the average was, right? And you have to figure out, how do you aggregate these or find the patterns or identify the trends so that you're using what fits your purpose, your study. And then the other piece that I didn't mention, and I should have, is outliers. I think we've all been presented with those. Anybody who's looked at birth dates in IMPC knows there are some really ancient people in the IMPC. I don't know if you're aware of that, but like 150, 200 years old, because things get inputted incorrectly, right? And so you have to find these outliers and decide what to do with them as well. And then the data you have may not be exactly what you need, but you might be able to take what you have and compute what you need, right? And so you have to think through, does it answer the question? How can I make it answer my question, et cetera. And then the other piece I'll add for the theme of it's not that simple is you don't know what you don't know. And this is what makes me nervous about the availability of all of the statistical packages and things. You don't know where they came from. They might seem easy to use, and then you start going and they're really much more difficult or much harder than you thought. And I think partially because I feel like I've fallen into this trap, you can become an expert because you've watched the YouTube videos and you've figured out how to do it, but that doesn't mean you necessarily understand how to make the right inferences or understand the output that you're looking at, right? And so you can maybe get a little bit of false sense of security around your results. And the methods may seem easy on the surface, right? You might think, oh, creating a propensity score is no big deal. You just figure out how these people match up. But there's a lot of work that goes into that with weighting and identifying the variables. I'll stay out of the technical details, but sometimes things that seem easy on the surface, truly understanding how they operate takes time and training. And that leads me to why you need data scientists. It's what we do. So what does a data scientist do? In short, a data scientist is the person on your team with the ability to process and interpret the data. So a data scientist's skill set is going to include data wrangling, which I will define in just a second, visualization, analysis, and then some of these more technical skills like machine learning and deep learning, because when you have these very large and robust data sets, sometimes what you need to do is let the data teach you, let the data show you where the patterns are. And there are techniques for doing that. And so they'll have that background as well. But I think data wrangling is probably one of the most important, and so I'm going to spend a little bit of time on that. So data wrangling is a term used to capture what a lot of people probably call the cleaning processes associated with data. You've got to transform this raw data set you're getting into something that's ready for analysis, right? And I think that's where a lot of people misstep right off the bat is they get handed a data set and they think they'll just be able to analyze it right from the get-go. But you need to spend some time with it. And so the first stage in data wrangling is discovery. Get familiar with the data set. Do you see any obvious trends or patterns that might be denoting an issue? Like if you have a data set where you expected 90% of the people to have a particular lab value and it's the opposite, you might have a problem. And so spend some time getting familiar with your data, understanding what's in there, structuring the data, which might sound easy, but sometimes you have to take this raw data and put it into a format that fits the analytic need. And I'm not just talking about CSVs to SAS files or things like that, although that might be part of it. But it's thinking through, how are we going to use this data? Do I need to make calculations from these different elements to create new variables and things like that? Cleaning, this is the step that I was mentioning earlier related to outliers and obvious issues. You've got to think through, what is my parameters for these certain variables, and am I seeing outliers? And data scientists have methods for doing that. They have visualization techniques and methods for identifying these patterns so that it becomes easier to do this. And I guess the other thing I would add is this data wrangling stage is not happening in a vacuum. Your data scientist is not doing this, alone. They're going to be presenting you with sort of steps and outputs along the way, saying, here's this visualization of the missingness on this particular variable. You as the clinician, or you as the subject matter expert, does this make sense? Right? Because sometimes it does, but sometimes you're like, no, nobody is going to be 200 years old in this data set. That's not happening. And then the other piece of it is enriching the data set. So like I was talking about, you can merge in all of these different data sets. And so you might need to spend some time and determine whether you have what you need, or if you need to augment it with something else, go chase publicly available data points, or pull in some county details, whatever it is you're trying to do. And then an important step is validating it all, right? Verify you have the analytic data set you were hoping for, that it meets your parameters, that it's going to answer your research question before you get going. Because the goal is to have an analytic data set you feel confident in. You understand the intricacies of it, you understand where your problem points might be, which helps you understand your inferences down the road, right? If I know I have an issue here, then I can adjust my takeaway message down here. So a piece of data wrangling, but then also the project on the whole, is data visualization techniques. So data scientists have backgrounds in representing this information graphically. I know when it comes to looking for outliers, this helps me better than just looking at some ranges and things like that, because it helps me see if there's a pattern in the error, or do I just have a couple of outliers, right? So in my birth date example, if I have a couple of people who are 200 years old, then I've got a data entry problem, and maybe I can look and fix it, and maybe it's obvious. But if we're seeing, this bizarre trend with birth dates, we might have a problem overall. That's kind of an easy example, but that's what you're looking for, right? You're looking to see visually what's happening with this data set. So this is very helpful in the data wrangling stage, but it's also helpful as sort of an initial precursor to your analysis. It gives you kind of this first look at what patterns and trends are we seeing, and do they make sense with what we were thinking, starting to move towards your analysis, right? And then you can also use this step for your outputs, for your dissemination, because as you're working through this, you'll get better ideas on how to portray the data at the end, and your data scientist is going to have knowledge and experience with different types of visualizations, right? And so we aren't necessarily all just stuck with table one. Maybe there's a better way to do it, right? For those of you who read a lot of papers, table one is always the one that talks about the cohort. All right. And then there's the statistical considerations of a data scientist. They're not replacing your biostatisticians. And then depending on your project, you may need both, or maybe not, depending on what your needs are. But data science is a bit more of a multidisciplinary field. You're going to have backgrounds in scientific methods, data management and extraction, and then some of them are going to have those advanced modeling and machine learning techniques that are really helpful if you're working with the really big data sets. And so you're going to have statistics backgrounds, computer science backgrounds, things like that. A lot of data scientists focus on modeling. So you choose a couple of different models, and you see how they perform, and you evaluate the performance of those so that you can choose the right one, working towards your end goal. So a lot of data scientists focus in things like predictive modeling. And then one piece I think is really important that the data scientists bring to the table is communication skills. So we understand the data. We hopefully can help you talk through the data and produce visualizations for dissemination. And so I think that's really important step throughout your entire process, because if you don't understand, and I've said this probably a couple times, it's because I think it's really important. If you don't understand the data you're looking at, you aren't going to understand your inferences that you're making from them, right? And you might somehow bias yourself or come up with an incorrect interpretation. And so you want to be thorough the whole way through. So just kind of in summary, data scientists know data. And I don't mean we know all the data or we know your exact data, but we know how to familiarize ourselves with your data. We know how to work with it, to enrich it, to examine it. We leverage our experience from the past to help make your projects better. So getting us involved early, I think, is a helpful step, right? We can help you ask the right questions from the beginning even potentially identify the right variables to be asking for from your data source providers. And then we start right in with that data wrangling, right? That important step of making that analytic data set so that you have confidence in your analysis. And then we can apply statistical techniques as well, right? And so we're there sort of through the whole process. So hopefully I've made the case that data scientists are good for health research and should be leveraged more. I don't think every health or medical study is going to need a data scientist, but I think increasingly it's becoming more common that studies should consider adding them, especially if you're merging data sets or you're working with, the sort of ever growing and larger cohorts of data sets. So with that, I will say thank you for your time. And what questions do you have?
I have one.
It's not on.
Okay, now it's on. Good. So I'll start by saying I don't think this is an easy question to answer, but I think it's worth a discussion. You mentioned that data scientists do not replace biostatisticians. Where do you see data scientists and biostatisticians' role overlapping, and where do you see them distinct?
That's a good question. And you're right, probably not an easy answer, although I think if you Google it, there's probably pages dedicated to this conversation. I think statisticians, and not all, right? I'm not going to generalize, but in general, I just said I wasn't going to do that. Statisticians, especially the biostatisticians, they're going to be trained in statistical methods for regressions, ANOVAs, right? Like producing those statistics around your data set. Data scientists are going to be more accustomed to working with large data sets that are in need of multiple modeling techniques or a lot of enrichment or wrangling. I think that's sort of where I see the division. If you think about kind of my traditional health study example and then these kind of advanced ones, that's where I think you see the division. And I think why they overlap is because there's a lot of studies we do in health research that need both, right? You need somebody who's working with the data, identifying those trends and patterns, but you still need that person who is well trained in the statistical methodology to implement these statistics that are, well, frankly, for the peer-reviewed journals, the methodologies that require for our rigorousness to get published. And so I think that's where you're going to see the overlap. And I think some studies are going to need both. Some studies are going to need one or the other. And I think there are statisticians now who are wearing both hats for sure.
To make sense of health data science takes a combination of both data science, how data become information, knowledge, understanding, wisdom, that dichotomy, that taxonomy, but also clinical knowledge. And it's uncommon to have people like Sean, who is both a clinician and a data scientist. All right. Normally, you have data scientists that don't know much about clinical medicine, or clinicians that don't know much about data science. And if they work together, they'll learn some of the other person's discipline. Like I know that Faye has gained a lot of clinical knowledge just by, helping answer clinical questions. But usually with somebody who can work as a translator between the clinicians and the data scientists. So because my first question is, what is the role of the partnership, or what is, would you encourage a partnership so that we can, it takes both disciplines. I'll give you an example. Did a query once on peripheral arterial disease, right? And if you look for a diagnosis, you'll get people who generally coming in to get surgery, You may not have people who have symptomatic claudication, but it doesn't reach the level that it becomes a problem on a problem list or a billing diagnosis or something like that. And then you have to know that, well, it's the external extremity Doppler exam, which is the study where you measure this, and that an ankle brachial ratio of less than 0.5 indicates that somebody has disease. Well, you don't know that if you're a data scientist. You may know that if you're a clinician. So I guess my first question was how, I mean, it seems like you would have to encourage that relationship, but it doesn't seem to happen spontaneously. You know, the data scientists live in their little, you know, the little cave, and the clinicians are off with their patients, and the investigators live somewhere in between those two.
No, I think it is critical in that iterative process of visualizing what's going on with the data. I don't see how a data scientist does that on their own unless they happen to be Sean or maybe Brian with certain, right? Like you and Bill Tierney, yes, of course.
Whoever he was, yeah.
You definitely have to foster that. And I think working with Data Core, we've seen that a ton too, right? Like the partnership is critical. And I think it is, I'm going to put it on the data scientists to help foster that, right? They have to come ask when they need advice or when something looks funny or where to go to look for that, you know, a certain piece of data or whatever. And it's a challenge to form those bonds, but I think it's critical, and it's a big part of that communication piece that I was highlighting.
And if you go back to your slide that has the boxes that say discover and replicate and clean, et cetera, because there's a point I want to make about that too, is that you just said the word iterative. This is not a straight line process. That you'll find something as you're going through and either cleaning the data or structuring all this stuff and go back and say, no, I need more data.
Yeah,
you learn something about the data that's representing the clinical problem you're trying to understand, and you want to go back and get more data that will reduce the uncertainty of the things you're getting out of it. And I think that's important for the users because they think that this is just a vending machine. You push a couple buttons and the data come out. And they say, no, it's a process and you have to be involved in it. And it's going to take weeks. It's not going to be, you know, just push the buttons.
Nope.
And so I think that there should be a looping back. I'm not very good at visualizations, but showing that you keep learning about what you're studying while you're studying it. You don't come in actually knowing the data, how the data are represented for the clinical or research problem you're trying to understand.
Yeah, I fully agree. I put iterative process on number 3 there, but you're right. It should have also been on number 2. And I was looking at Faye and we were chuckling because just yesterday I was saying that because, you know, and going back to my heart rate example, right? Because data has become so ubiquitous in our lives, I can get to my data so easy that everybody thinks it is a vending machine. Just give me the data and I'll figure it out. But it's not that easy to figure it out. And it's honestly usually not that easy to give you the data either, right? Like there are complex processes that are involved in identifying these variables, in creating these data sets, in creating the analytic version of the data set. And it's not a vending machine. And I don't know that it ever will be. You know, I don't think it's ever that straightforward or simple.
I've got one. A lot of great.
No, thank you. Thank you, everybody.
So I think you did a great job setting the context of why we need data scientists. I'm curious to get your thoughts on this. So tomorrow, we're not going to have less data. Next year, we're not going to have less data or fewer data sets. We're going to have more and more and more. And so it seems to me that we are in the uptick of the hockey stick on the need for what you're describing, because as we get more and more of these collected data sets that have all of their idiosyncrasies, we need more people to be able to perform this process. Today, I can imagine some people listening to talk say, well, I know my data. I know exactly, you know, how to deal with it, and I've been pretty successful. Do you believe it's the case that over time, more research will be conducted with pre-existing data sets and therefore we will need more data scientists?
I think the short answer is yes. I think I've seen that since I started, right? Since I started here in 2008, we've seen an increase in data cores data cores requests, the number of people who are requesting secondary use of data. And I don't think that's going to slow down. And over the last couple of years, what we've also seen the increase is in the merging. So either merging of publicly available data, merging of collective data, right? We're in all these consortiums. And even that requires, there's data scientists on those teams as well, right? Because you can't just take the data from Indiana and the data from Kaiser and smash it together. It's not going to be that pretty, right? It's never that simple. And so I absolutely think data scientists are going to become more prevalent in the research community. And I was on a consortium call, it was Monday, and there were 3 of us out of probably 10 or 12 with data scientist as our title. And I think it's just becoming more popular because you're right. I mean, the amount of volume, the volume of data generated and the ease at which we can get to it is just increasing.
Unless there are any other questions, why don't we thank Amy for a great talk.